If it doesn't know the type of the cluster, then it can't know the names of the elements, and it can't provide you with this list of elements to select. And secondly, it provides the input data to the cluster. You don't have to wire data into all of the elements in a cluster with each bundle by name. You could update just one or two elements within the cluster. As a result, you need to pass into the bundle by name function the data value of the cluster first. So with that in mind, let's take a closer look at the data coming in on the wire to the bundle by name function. What we have up here is a constant. We can tell by the shape of it and the fact that there's different types of data within it that this is actually a cluster, and inside it is contained the watchdog device ref cluster, the joystick device ref cluster, and the robot drive device ref cluster. Well, what we want to do now is to add a servo and a gyro. So we know that we're going to have to add WPI library functions to open both of those objects. So let's do that right now. We'll go to the gyro sensor open, put that down. We'll wire up its analog channel by creating a constant on the analog input of AI1. And let's also add the servo. So again, WPI robotics library, actuators, servo, open. We'll wire up the channel, which again is PWM9. So we've used these functions now to open up device references to the gyro and the servo. So if you remember from the basic robotics framework, we had to wire these device references into the main code so that we could use them for the gyro get and the servo set angle. And if you remember even further into the autonomous mode modifications for the basic, is that we had to put that data type into the robot global. By putting it into the robot global, we then made those device references available for the autonomous independent VI. So what we have to do here is actually quite similar, because if you notice, there's nowhere to wire in this gyro. If I make a little bit more room and I stretch this down, I don't have a gyro device ref here. So what I need to do is I need to create that. And remember, the definition of this data type is coming from the wire on the middle element, which is coming from this constant. So now let's take a second and talk about typedefs. If we right-click on the very edge of this robot data in constant, we see that in our context menu we have the option to open typedef. If we choose to do that, then this window opens, something called robotdata.ctl, which is a strict typedef. This is very similar in a lot of ways to a global variable. In the same way, if we go to the window, there's no show block diagram. The reason there's no show block diagram is there is no code behind this. It's strictly a data type. And if we go back to our project screen, we see in our typedef section, here's the control called robot data. So this has been pre-created for us, and because it's sitting here in the root of our project, we can make modifications to it. So let's do that. Just like we did when we wanted to add a device ref to the global in the basic framework, we're going to open the gyro open VI and just copy this device ref. Go back to our robot data control and paste it in. So it's important to note, just like when we have a broken VI, we have a broken run arrow, when we have a broken control, we have an OK with a slash through it. The reason this is an invalid control is because the type def of this is a cluster. So you can have different clusters within a cluster, but you can't have two clusters sitting side by side like I do now. So what I need to do is I need to take my gyro device ref and put it into my robot data. And you notice as soon as I do that, my broken control indicator goes away and everything is fine. So one recommendation I'll make right now is, because you're going to be adding a lot of stuff into these typedefs, is to always keep them cleaned up. There's a couple different ways to do that. If you right-click on the very edge of the typedef, under auto sizing, you've got a few choices here. The first one you're going to want to use, at least, is size to fit. And if you do size to fit, what you'll notice is if you move the gyro device ref around, then the whole cluster is going to adjust so that you can see everything. And another option, and this is the way that I always like to work, is to choose either arrange horizontally or arrange vertically. I like arrange vertically. And what that does is it packs in all of the elements in this cluster so that they're vertically compressed, and it auto grows the cluster to fit them all in. So now we're going to close and save this typedef. And if we take a close look at this now, we see there's a new element. And one of the really nice things about typedefs is they propagate throughout your entire code. So once you've made that change to the typedef, look what happens when we access the bundle by name. Your gyro device ref is now available. So the object we want now is all elements from the gyro device ref. And now what we can do is wire directly from here to that input. So let's repeat that process now to add the reference to the servo. So we're going to open the servo OpenVI. We're going to copy the device ref. We're going to right-click to open the typedef. We're going to paste and drag it right in. And before I drag it in, let's give it a proper servo name. And then we're going to save and close the typedef. And when we pull this down, we'll find we have our new element available. So that's a very quick introduction on how to modify typedefs. We're going to see the real benefit of typedefs in just a second. So let's return now to make the modifications to our teleop code so that we can have our gyro driving our servo. So we're going to save and close this VI. And then either from the project window or from the Robot Main.vi, we can open up our teleop VI. So something interesting to take note of now. Here we have our robot data in. If we scroll down, we see two really useful things. Our gyro device ref and our pan servo. So that's the real beauty of a typedef, is that if you make a change to that typedef from anywhere in the entire framework, that change is going to propagate everywhere. Just like when you use sub-VIs to encapsulate a chunk of code that you're going to reuse, you use typedefs to encapsulate a data type. And then when you reuse that data type throughout your framework, that data magically becomes available everywhere. So let's take a look at the block diagram again. So here's our robot data in. We just saw that on the front panel. So not surprising, if we pull this guy down now, we have available the gyro device ref and the pan servo. If we return to the execute stage, which is where we're going to make our code modifications, now we can add the same code that we added in the previous example. We want to do a gyro read. So from our WPI library, sensor gyro get angle, hook up our device ref to the output of our unbundle by name, and we're going to do our servo set. WPI robotics library, actuators, servo, set angle. So we're going to connect our angle out to the angle in of the servo, and we just need to connect our device ref now. So I'll let you decide whether you think this is significantly more difficult than the basic framework. My personal opinion is that this is a more robust approach to programming for a couple different reasons. Number one, because everything is nicely encapsulated, it's very easy to create modular code, and it's very easy to allow multiple programmers to be working on different parts. If you were to envision the basic Robot Main.vi, basically you have all that stuff sitting on one screen. And so it would be very difficult for multiple programmers to work in parallel. Also, you can imagine how that screen is going to get bigger and bigger and bigger the more stuff you add. Here, because you've got the begin.vi, which is opening all the references, separately from the teleop.vi, which is doing the execution, it's a lot easier to manage your code, and it becomes a lot easier to take care of screen real estate. So one thing those of you who are watching really closely might have noticed is that the joystick device ref wasn't opened in the begin VI. Let's just return back to that for a second.